Alright, so we are back in AP Calculus. Today's date is Monday, May 6th. We are doing our final review. This is Monday, so review 3, I guess, for final exam number 3. The Monday packet, so this is what the Monday packet looks like. Before we start talking about this other problem, I also want to talk about this. Oh, it's the same problem. Okay, well that makes it really nice. I can just go over this problem instead of going over the final exam, since it is the exact problem. It'll go a little bit faster today then. All right, before I talk about this problem, how did we do? On problem number 1, it looks like we did really good. So Arrow and Ben, who are not here, got 6s and 9. And then Rochelle, who is here, say hi, Rochelle.
Hi.
Got a 5. And then, of course, if I had to choose any problem to go over in depth, it looks like Arrow, there's some easy points to get there. Everyone else did really good. And then maybe problem number 6, how to get more points on that one. But overall, everyone did really, really good on the free response. Like, look at these scores, 44, 48. Again, you're supposed to be averaging 33% to get that 5, and we destroyed. Yeah, so we're doing good. Our multiple choice is the sections that we need to spend the most time on. Let's go ahead and do this one. So concert tickets went on sale at noon. So it's kind of important to know that noon is when t equals 0, which kind of messes up some of the problems. A is saying use the data in the table to estimate the rate at which the number of people is changing at 5:30, so 5.5. So at 5.5, we can see 5.5 is right here. So I'm going to go and say the secant line here is going to be 150 minus 126, all of that divided by 7 minus 4. And that is going to be 24 on the top and 3 on the bottom, which is equal to 8, but we do need to indicate units of measure. So it's asking for the rate at which people are waiting in line is changing. So it's people per hour. People per hour. And if you didn't know how to get that rate, another way to know that is you're doing this thing divided by this thing, people per hour. Questions thus far, Rochelle? Got all the points so far? All right. Did you get all the points on part B? You probably missed the average, right? Yeah, so this one was tricky because not only do you have to approximate using a trapezoidal sum, which everyone did correctly, you need to make it the average.
So if they say the total number, then that's when you don't have to put the 1 over 4.
Exactly, yeah. Total number, you don't need to put a number out front. Whenever there's an average, you always need to do 1 divided by b minus a of that integral. And again, our integral that we're talking about here is going to be approximated by this trapezoidal sum. So I'm not even going to write this integral symbol. I know it's going to be a trapezoidal sum. For the first 4 hours, it's this data right here that I'm looking at. Everyone did the trapezoidal sum, so I can go through that kind of quickly. That means I'm looking for the average between these two, and then I do the interval from here to here. So intervals, 1, then 2, then 1. You just subtract, like 3 minus 1 is 2. And then the average here, I'm going to add them, then divide by 2. This is a calculator problem, which means I can open up my calculator here and say, yeah, what is 120 plus 156 divided by 2? That's going to be 138. So I come down here and say this. Maybe I can even change this right now because I know that my interval is going to be, come on, computer. I know that my interval is going to be 4 minus 0. So 1 over, let's go down here, 4 minus 0 of the trapezoidal sum, which
So if they're asking the average number between 1 and 4, would it be 1 over 3?
It's so you said between 1 and 4?
Yeah.
Yeah, it would be because 4 minus 1 is 3. Exactly, yeah. So 138 times the distance, the interval. Distance was 1 here. So I'll write down 138. And then 156, 176. Oh, that's easy to do. That's 166 because I can just do that in my head. And then this guy, this one is also easy. This is going to be distance of 50. Okay, so it's a little bit harder. It's 25, so it's going to be 151. 51. And I can just check that in my calculator as well. 176 plus 126 divided by 2 is indeed 151. Okay, cool. So, and then I just need to know 166 is multiplied by 2, so plus 166 times 2 plus 151 times 1. And I guess I should use a square bracket there. Now I need to add those up. So 151 plus 166 times 2 plus 138 is equal to 321. So that is equal to 321 divided by 4. And then when I actually divide that by 4, divide by 4, and I get 80.25. 80.25, 250, I guess if you want to put it there. And what did we actually put for our solution guide? It says you need, what did we, oh, I messed up on. What did I do here? I should get a 155.25, so I messed up. Where did I mess up?
Oh, you did.
I did, but this
No,
number.
I got 621, not 321.
Yeah, what happened there?
So do.
Oh, 16. Okay, I messed up by entering in my numbers. It should be 321. Or sorry, 621. My bad. I was going too fast on the calculator. And I was going to say, that doesn't make sense because all of these numbers were bigger than 100, so this average should be bigger than 100. Let's come back here. It should be, God, I can't enter this correctly, 621 divided by 4. 155.25, which is what we got right here, 155.25. Slight sniffle, so my nose is not with me today. 155.25. All right. Do we need units on here?
Yes. People.
I guess if it didn't say to do units, it'll usually say indicate units of measure. But we should do the units just in case it does ask that. So this is the average number of people. So average number of people is number of people. Our units are whatever it's asking for. So average number of people, the answer is people. All right, there's that answer. And then part C. What is the fewest number of times which the derivative must be 0? So this is talking about slope, I guess. And it's a little bit hard to figure out even with a calculator, but let's go ahead and kind of see what's going on here. So from 120 to 156, I'm increasing, then all of a sudden I'm decreasing, and then all of a sudden I'm increasing, then decreasing, then, bless you, then decreasing. So we can tell, we don't know exactly when it happened. It could have happened between 156 and 176, or it could have happened between 176 and 126. But clearly there's this going up and then going down, which means I have a horizontal tangent, this horizontal slope around this point 176. Do you agree, Rochelle? That means I also have a horizontal slope right around here and a horizontal slope right around here. So there are 3 of those. There's 1, 2, 3. And again, it's asking for when you have a horizontal slope. The slope is 0. So the answer is 3, and it's on those intervals. And you have to be careful about how you explain this. So the answer, of course, is 3. 3. You only get 1 point if you say 3. You get 2 points depending on how you explain. And let's come back here to the solution guide to see what they're looking for.
What's the third point?
I'm about to explain that. Yeah, so for part C, 1 point is the conclusion that the answer is 3. There's a few different ways that you can do that, and I actually prefer doing it this way because it does have this OR statement. You can use MVT or you can use IVT. Does it even say IVT anywhere in here? It actually used EVT, extreme point, but I think you can use IVT as well. The analysis is just 1 point, but you also need to consider relative extrema, or you need to consider the slope sign change. So whichever one you want to use, I will use relative extrema because that's a little bit easier. So I know that there should be a relative extrema somewhere between 156 and 126, because between these 2 points I have this red circle. Does that make sense? Okay. Kind of. Well, I know that 156 and 126, there's a bigger number in between, which means somewhere in between 156 and 126 I will have a relative extrema. So 3, and then you can say because on the interval 156 to 126, or I should say on the interval 1 to 4, there must be a relative max, which implies that f prime is equal to 0 at least once. On the interval, there should be a relative minimum in between these points, between 176 and 156, because it goes down to 126, so between 3 and 7. On the interval 3, 7 must be relative min, and then same thing, there should be f prime is equal to 0 at least once, and then finally on the interval, and then the next one is going to be between 126 and 80. There should be some sort of relative max, so between 4 and 8. So on the interval 4 to 8 must be relative max. Again, for the same reasoning, there must be f prime must be 0 at least once, and then all of that by EVT, by the extreme value theorem. Cool. I think that is all the explanation I need. And notice that it's asking for, so it's considering relative extrema. I did that. The analysis is noting that EVT means that I have f prime is equal to 0. So I'd get that point. Again, there's the other answer key if you want that. And then finally for part D, almost done here. For part D, the rate is modeled by this based on the model how many tickets were sold. Okay, so this is the key point. This is a rate. The rate is given by this thing. So if I want number of tickets, I need to go backwards. I need to take the integral. So this is going to be the integral of RT for whatever bounds it was talking about. RT on the bounds between 0 and 9. So come back here on 0 and 9, and I just plug that into my calculator. So I'm going to say this is approximately equal to, using my calculator, scrolling up here. Oh no, my function is right here. So I'm going to do math 9. My function is 550 x second natural log to do e to the power of, and then it's going to be negative x divided by 2. All right, so that's my entire function, comma with respect to x, comma from 0 to 9, 0, comma 9, and I should just get an answer. Ooh, what happened? Is that the right answer? 2065? No. Oh, I see what's going on. Based on this model, how many tickets were sold by 3 p.m.? So
you did it from 0 to 9.
I should be from 0 to 3, so that's my bad. Come down here. Let's actually read the problem and say, yes, it is from 0 to 3. While that function does work on 0 to 9, I'm only looking for 0 to 3. So I come back here, second enter, and come back here, change that to a 3. If I hit enter, I should get, there we go, 972, and the answer should have been 972.784. 0.784, so let's write it down. 0.784, and then our answer was 973, and then what are our units here? Tickets. Cool. Questions, Rochelle? No? You think you get more points next time? All right, so.
It's just the average from B.
Yeah.
And for D, I wasn't thinking because I thought it was just asking for like at 3, not like from 0 to 3. So that's why I did the integral from 0 to 3 of RT.
Yeah, the main thing to know if it's an integral, if it's given a rate and it's looking for a number of tickets, many tickets, you need to take the integral. All right, number 83. And then I should pull up the stats for this, but I guess number 83, this is in that second section. So Arrow, you got 32%, Ben, you got 61%, and Rochelle, wait, yeah, that's right. And then Rochelle, you got 14%. So this is from that section. So number 83, the area is this guy between here and here. I don't even know what they are, but I can immediately just do one minus the other on the calculator. So if I pull up my calculator, I'm going to again do math 9, and I'm going to do one function minus the others with parentheses around one of them, or I can just distribute a negative into the negative x, negative 5 right here. Either way, so I'm going to do x to the power of 3 minus 8x squared plus 18x. Okay, that's the first function. I need to subtract the other function. I know that it doesn't matter which one is on top and which one is on bottom. I know that the area should be positive. So if I get a negative answer, just make it positive. Now I'm going to subtract, in parentheses, this function, x plus 5. X plus 5. Okay, this now represents one function minus the other function. Now I say with respect to x. Oh, now that's the other tricky bit. What are the bounds? So maybe I don't want to do it this way.
That was hard about that one.
Yeah, it is a little bit tricky. I think we actually had to come back here because we don't know what the bounds are. You just want to graph both of them and find the intersection. So graph both of them. So sorry about that. It's going to be x to the power of 3. I have to do this all over again. X to the power of 3 minus 8x squared plus 18x minus 5. That's the first function. The second function is just x plus 5. X plus 5. Our window, I'm going to leave it default. Hopefully it'll be on there. Zoom 0. I know that x to the power of 3 grows really, really fast, so it might not be visible. Yeah, it's a giant function down here. I'll have to zoom in here. Graph, graph, graph. Okay, obviously that didn't work, so I'm going to make this smaller. I'm going to zoom into this area right here. So I'm going to make my window from -3 to 3, or I could do -4 to 4, somewhere around there. Let's zoom 0 that. Hopefully that'll work now. You can tell that the y-axis was super zoomed out because it was such a solid line. It's still super solid. Okay. Yeah, let's try 0 to like 4. Zoom 0. It's all trial and error. Obviously, if I picture that in my head a little bit better, I would know that that's always in the positive section. Go function, go. Hey, now it's pretty clear that it's between there and there. This is the little piece that I'm looking for. So if I want to zoom in even more, I could go between 1 and 2. It looks like it is going to be exactly 1 and exactly 2. But to double check that, second trace to do the intersect, 5, enter, enter. I'm going to guess about 1. And it is 1. And then you can check the other one as well. So I'm going to guess, so enter, enter, I'm going to guess about 2. And it is exactly 2. So if I actually come back here, I can do my bounds from 1 to 2 and then be done with this. 5.58. Uh-oh. Uh-oh. What happened here?
Wait. Did you do like the whole like x cubed minus 8x squared minus x plus 5?
I did. What did I do wrong?
Can't really see.
Huh. Thought that should have worked. Did I enter something wrong? X to the power of 3 minus 8x squared plus 18x minus...
Oh, minus 5.
Minus 5. Thank you, Rochelle. Log it. You get all the XP to yourself. So I'm going to do second insert minus 5 and then minus all that. So let's try that again. Uh-oh.
What?
Minus 5 minus x plus 5. I still didn't get the answer. What is going on? Did I... entered it here correctly, x to the power of 3 minus 8x squared plus 18x minus 5x plus 5. I know that my graph never intersects. Oh, does it intersect again? Oh, shoot. It does intersect again, probably.
So they're asking the big picture, the big area.
Hold on. Let's zoom out here to 8. Zoom 0. I think
so do you think it's going to be from x of 2 to something?
I'm going to have to break up the integral. Ooh, that might have been too far.
No, I think that's good.
Ah, shoot, that one right there. So I don't need to go that far.
Why
I could have
don't you
gone.
go from 0 to like 7?
Yeah, I think 6 would have been even better. Window, wait, zoom 0. Shoot, I didn't even realize that it would intersect there. That's why we weren't getting the right answer. Obviously, at this point, I would probably give up and move to the next one unless I was really, really close. But yeah, I should intersect right about there, which means I have to subtract that area. So that area right here is basically meaningless. It's basically a half. But if I come back here to my graph, I have to figure out that point. It looks like it's about, what is that, 6, 5, something. So if I do second trace and then intersect, enter, enter, I'm guessing about 3, 4, 5. It's probably exactly 5. It is exactly 5. So if I do second quit, second enter, between 2 and 5 now, 2 and...
wait.
5.
But here's the thing.
So I have to do this one, and then I have to add it to the other area. So I'm about 11.75. Which one of these is about 11.75? This one. Correct answer is B.
Are you sure?
Yes, 100%.
Because, like, I don't know, it's just, it might be right, but it's just the fact that, like, when you go to calculator, you re-put in what, like, the old formula that you just put it in, right? The F integral something.
Yep.
Of, like, x cubed, something like that.
Mm-hmm.
Shouldn't it be x plus 5 minus x cubed? Because on the table, sorry, I can't speak. On the graph, the x plus 5 is the one on top.
So it doesn't matter. I know that I'm just getting a both of these. Okay, so how do I put this? In a graph, if I have a graph that looks like this, where I do, and I have another graph that goes, maybe I should make that a different color so you can easily distinguish it. You always do top minus bottom, which means this area, no matter what, area is always going to be positive. Area is always going to be positive. It just changes whether or not you put blue function first or blue function second. But you should always be getting a positive area. So I got a positive 5.8 because I did it correctly. But I did this one backwards, so I have to make this positive 11.25. So positive 11.25 plus positive 0.58 does equal positive 11.833, probably repeating, yep, repeating.
So if you ever get a negative number, that means you just have to make it to a positive and you're done?
Yes, when you're talking about area. But the one thing that most people make a mistake here on is they'll do this. They'll say, oh yeah, I can just do all of it at once, and they'll do 1 to 5. The problem now is these are actually canceling each other out, and you'll get 10.667. That is not correct because that's assuming one of these is negative, which again is not correct. You do need to separate this integral, and that point here was at 2. It went from 1 to 2 to, what was it, 7? What I put 5. So you do need to separate it and to find one integral, find the other integral, and know that both of the areas should be positive. All right, so if they do cross, make sure that you do separate it, make sure that both of them are positive. On to number 85.
So it doesn't matter how you put it into the calculator as long as it's both positive?
As long as you separate the integral and make them both positive, you're good. So number 85. F prime is continuous. That's good to know. I'm looking for this value. So if I take the integral of the derivative, I'm going forward. So this is really f of x, evaluation bar between -4 and -1. Antiderivative of the derivative is just this thing. I still have a definite integral, which means I need my evaluation bar. Sounds good? All right, so from here, that's going to be f of -1 minus f of -4. Well, what is f of, I think I'm doing this right, f of -1. F of -1 is -1.5.
Oh, no.
1.5. And then f of -4 is 0.75, so minus 0.75. I get -2.25. Correct answer is B. Yeah, you don't need to do anything with f prime. They did lead you astray there, which is kind of weird because usually the AP test doesn't do that. But I guess maybe the information that they give you here doesn't lead you astray, but they can lead you astray in the table. I do know for a fact they do sometimes give you random things that you won't be using in the table.
Why do they do that?
Because they need you to choose between f and f prime.
To say we're right? Like if we know it?
If you know it, yeah. This f prime is just a red herring. They put it there to confuse you. Number 86, another table. This is velocity, and it's looking for a graph of position. So these are graphs of position. So on velocity, if I'm looking at height, and these are heights, what does that mean? We skipped 84. I can go through 84 if you come in at lunch or after school today. Today, I'm here after school until 4:30, and I can go over any single problem that you want to know. Number 86, on a graph of velocity, height is the same thing as a slope on graph of position. So height and slope, those are the same things. So these are the same things. Height and slope. Height on velocity is slope on position. So if I'm looking for, this is an easy one. I'll have a slope of 0 at 3. So at 1, 2, 3, I should have a slope of 0. So 1, 2, 3, 1, 2, 3. Okay, this one has a slope of 0. This one didn't. This one didn't. 1, 2, 3. That one has a height of 0. 1, 2, 3. Okay, so I'm between C and D, C and E, just knowing that I have a slope of 0 here. What other information do I know? Okay, the biggest thing that I see between these two graphs is the slope at 1. The slope at 1 is positive here. The slope at 1 is 0 here. So let's come back and look at heights.
So
At 1, my slope was positive or 0?
positive.
Which means the answer is?
C.
There it is.
And I was actually going to choose C, but
Look for the easiest thing. The hard thing is figuring out that height on velocity is the same thing as slope on position. Knowing that relationship, then you just have to choose nice numbers. The nicest number is 0, so that's what I did first, and then I just had to distinguish between the two. The biggest thing that was distinguishing these two graphs is what was happening at 1, the slope at 1. Cool. Questions, Rochelle? All right. Number 90. Cool. All this thing is really nice. Twice differentiable, which means we're allowed to take the derivative twice. It tells us our starting position is here.
so we have to like add 2 for the first one.
Okay, yeah. So this is saying first difference is 2. It is 2 for all of them. I always add 2, add 2, add 2, add 2. And it's saying that the second derivative, it's negative for all values. So this is saying second difference is negative. All right, so which one adds 2, adds 2? Well, that doesn't add 2, add 2.
D.
This doesn't add 2, add 2. This doesn't add 2, add 2. This does add 2, add 2. This also adds 2, adds 2. So it's between D and E.
Wait, E doesn't.
No, it doesn't add 2. Oh, it's just D.
But the second derivative is a negative, though. It's always going to be 0, 0, 0.
What is going on? You're right.
So it should have been C, because the first one adds 2. But
Oh, it's just f prime of 3. Okay, so you're right. So let's back up here. It's just saying at 3, I go 2. So from 3 to 4, you should be adding 2.
Add 2.
So from 3 to 4, it's not A. From
So
3 to
it's
4,
B,
it could be B. From 3 to 4, no. From 3 to 4, it could be D. So it's between D and B.
So it's going to be B, because for B, you add 2.5. But for the second part, you add 2. So that's negative 0.5.
And this one,
That one is
2
just 2, 2.
and
So
2.
It's gonna be B.
so the first difference here works. Second difference here, you subtract 0.5. Second difference here is 0. It didn't say it was 0, it said it was negative, so you are right. It is B. All right, so re-explaining everything once again. So we're looking for a first difference from 3 to the next value of 2. So the second difference, 2, was only between D and B, and then from there we did second difference, which needed to be negative because it said that the second difference here is negative, and that limited it down to B. All right, cool, and that's all that I have for this video. I will get this key up because I have plenty of time here. We get out at 11 o'clock, which means I have 24 minutes in which to do the second part, which means, Rochelle, you can probably finish this up and ask questions about the rest of your test.